Hey, welcome to this video on Introduction to Neural Networks. So in the previous couple of videos, I've made it clear what we are going to cover in this course, starting from the foundations of deep learning to training our own deep learning networks using PyTorch. So in this video, we are going to see how a neural network looks, what is the architecture of a neural network and what is there inside of a neural network, because this entire term of neural networks is, it's like when we hear it, we feel that, okay, it's a huge network and so on, and I'm going to demystify all of that in this video. So let's get started. So initially, before jumping into neural network, let us look at a very simple machine learning problem of sentiment classification. So with you have a text, and I mean not just one text, rather you have a corpus of text and their classified labels. The labels are positive or negative. So basically you have a sentiment classification data set, and in that data set you have a lot of textual data, say IMDb movie reviews or something like that, and you also have the assigned labels, whether that review is a positive review or a negative review and so on, right? And now you have to train a machine learning classifier which should have, where you should feed in all the data that you have, and it should learn how to classify the new reviews which come, right? So in such a case, how do we solve such a problem? We create a machine learning classifier, as I said, and in that classifier we pass in the data. So in the data we have all the columns related to the text, like the different, like in case of text data, you can have the different words in the columns, and you also have the classified labels being positive and negative. And now based on that data, the machine learning classifier trains and it gives you the predictions. And in this case, the predictions are nothing but your classifications. So you feed in data, the classifier gets trained, and you get some predictions. So that is a standard process what happens. And if we just look a little deeper inside this, then what we find out is basically when you pass in some data, then your machine learning classifier applies some mathematical function on top of that data, and you get some probabilities as output. Now, say for a specific text or a specific review, the actual sentiment is positive, okay? But when you feed in that data and it goes through the mathematical functions of a machine learning classifier, the classifier produces that it is 70% positive and 30% negative. Now the classifier is correct, right? The classifier is correct that it is positive, but it's not correct with 100% accuracy. It's saying that it's 70% accurate, the sentiment is 70% positive and 30% negative. So using those values, you calculate something called a loss. Right now, you don't need to go deep down inside about what are loss functions and what really happens inside them and so on. I'm going to cover all of that in future videos, but just know that data passes through machine learning classifier gives you some outputs. Using those outputs, you calculate something called a loss, and that loss tells you how wrong you are, right? If you have a higher value of loss, that means your predictions are wrong, predictions are not correct, right? And if you have a low value of loss, then your prediction is correct. So you should always go towards the direction in which your loss reduces. So every time you calculate a loss, then you feed in that loss back to the machine learning classifier, and using this you improve the weights inside the machine learning classifier. Like whatever weights you have, you just try to fix the values of those weights, and you do this for a number of iterations, and you finally end up having a proper machine learning classifier which has the knowledge of predicting whether a given review has a positive or a negative sentiment. So that's pretty much what happens inside a machine learning classifier. Now the example that I just gave you, so this is an example of a traditional ML system. Now, what do I mean by a traditional ML system? So as I said, right, in that data you have some columns, right? In the text data you have some columns and you have some labels which you are trying to predict. Now, in between all the columns, right, all the columns which you are going to use in training, what are the columns that you are going to feed into the data? So that is done by you, right? So say you in the data set you have 100 features. And so you are not going to train on all the 100 features. You do some statistical analysis and you figure out, okay, out of these 100 features, I'm going to use these 15 features because the other 85 features are just there, like for example, one feature can just be an entity ID or something like that. And those things just don't make sense. They are not useful for machine learning. So you figured out that you don't need all those 85 columns. You rather need just 15 columns or features, and you are going to train your model on top of that. So here, you being the expert, you do the feature selection on your own. You tell the model, look, I know we have a ton of data, but we are not going to train on the entire data. Rather, we are going to train on these 15 features. So that is an example of a traditional ML system. Now there are also another types of ML systems, the other one being the representation based ML system. So what happens in representation based ML system is pretty much the opposite of traditional ML systems. So in this case, you don't tell the model that you need to train on these 15 features or these 10 features and so on. You just pass in all the 100 features that you have and you let the model figure it out. So you just have the entire data, you pass in the entire data in the systems, and these systems will figure it out to, like which features they should, use in their predictions and in their calculations and so on. So neural networks are a type of representation based systems. So in a neural network, you generally pass in all the data you have, then the networks figure out, which features they should give more importance to and so on. So again, what is a neural network? So neural networks are a class of algorithms that learn which features matter. So you don't engineer the features, rather the neural networks itself learns like which features matter. And now when we talk about the term deep learning, then generally it's like synonymous with neural networks. So whenever you hear deep learning, just know that, okay, we are talking about neural networks. There's nothing more to it. And finally, a neural network, it's not just, a monolithic system where you have like, this is just a huge damn network where you pass in some data and it does something inside which we don't know and you get the output. So neural network is not like that, and you are going to see it next. So here again, now we are going to talk about like the architecture of a neural network, or I should say that how a neural network really functions. So as a whole, if you see, then it looks like a monolith, right? So in this box, you have the entire neural network. I mean, it might look like a black box. You pass in some data and it gives you the predictions or, regression results or anything like that. It gives you that. But generally, it's not like that. It's like that never happens. Okay, so a neural network is not an entire monolith. Rather, what you have is layers. So you pass in your data to different, like to the first layer, then some information from the first layer passes to the subsequent layers, and like that, the data travels from one layer to the another layer to another layer. Like that, from the last layer you get the output. So it's not just a monolith system, rather you have a sequence of layers. Your data or your information passes through these different layers and you finally get your output. And that is how a neural network works. Now, the layers with which you directly interact in the neural network are called the visible layers. For example, the layer 1. So in this layer, you are passing in the input data. Now in this input data, you know everything, right? Like in which data point, what is the value of a specific feature. You have all the information regarding that. So that becomes this, that's what makes the layer 1 as a visible layer. Similarly, the last layer, layer n, it gives you all the outputs. So that is also something which is visible to you, right? And the layers which are between them, between layer 1 and layer n, are called the hidden layers, because you are not directly interacting with those layers. You don't know like what's going on inside them to that level and so on. Now, what's there inside of a layer? So again, when we talk about each of these layers are also not monoliths. Rather, each of these layers contain multiple different neurons. So here you can see that layer 1 contains some neurons, layer 2 contains some neurons, layer n contains some neurons, and so on. So a neural network basically contains multiple layers, and each of these layers contain multiple different neurons, and all of these neurons are actually interconnected. So basically the neuron of layer 1 is connected to the neurons in layer 2. Similarly, the neurons in layer 2 are connected to the neurons in layer 3. Then layer 3 is connected to layer 4, and like that you have till the last layer, which gives you the output. So yeah, that is pretty much how the neural network is. So basically, as I said, so the neurons in layer n-1 will be connected to the neurons in layer n. So you basically, now if we try to define a neural network, the definition that we get is like this. So a neural network contains multiple different layers. Each layer contains multiple different interconnected neurons, and neurons in one layer are connected to the neurons in the subsequent layer. And that is how an entire neural network works. You pass in the data to the first layer, then some calculations happen in the first layer, which we are going to talk about in future videos, and then the result for each of these neurons are passed into the neurons in the next layer. Then some calculation happens over there, then the output is passed to the next layer, and like that we go till the last layer, where we basically apply some kind of a method which gives us the probability of the different classes. So that is pretty much in a nutshell how the neural network looks like. So in the next video I will talk about a single neuron, because right now again when you see this, then you have a lot here to take, right? Now you have these layers, these neurons and so on. So I'll just pick one single neuron and I will tell you that what really happens inside that neuron, and what are these links meant, right? So all these things you need to know in order to understand this entire structure. So yeah, that's it for this video, and I will see you in the next one.